So hi everyone, and thanks a lot for joining. It's a bit different setup than you would used to have at a face-to-face conference. We'll see how this goes. Feel free to participate in the chat. I'll look there every now and then. If you have any questions or feedback, I'll be happy to hear them. So the next 45 minutes or so, we're going to talk about continuous delivery and DevOps. So let's look back at the old days. So some of you have been in the software industry for a while already. So please think back about the first time when you came into the software industry, and let me know through the chat how long you've been in software. Been in software for 1 year or 5 years or 10 years. Please let me know, because I'm interested to hear. 30, 20, 10, 15, 10, 40, 12, 3.5. Okay, so I'd say the experience of people is ranging from 2.5 years to maybe 20 or 30 years. So I've been in the software industry since about 2005. And I remember back in the day, we didn't have stuff like build servers and continuous integration. I was working at a company that made software for an insurance company. Everybody was working on their laptops there for the entire week. And then at the end of the week, it was time to integrate the software and deliver it to the customer. So all the developers in the company would then gather around and around this table where there was this mythical machine. And this mythical machine was the integration laptop. And with the integration laptop, people would go there and take burn CDs or zip drives, by hand copy it onto this machine, and then try to fix merge conflicts by hand, get a workable build, and then burn it to a CD or a zip drive and get it out there to the customer. While nowadays, if you use like a modern cloud system that can do CI for you, you just push something, and if you're lucky, it gets built automatically, the tests run, it gets deployed on a test environment, and if you're even really lucky, it gets deployed to production automatically. Also in terms of, if you think of servers, in the old days you needed to first get money, buy servers, put them in a rack, install your software, while nowadays you can just use your credit card, or even not even use your credit card, but get a free server and run your cloud environment there. So I'd say that in the software industry, things are getting better like every day, and we're actually in a field where the old days are not that good anymore than they are now. So my name is BertJanSchrijver. I work at Open Value. We have offices in the Netherlands and in Munich. I also run the NLJUG Netherlands Java user group. We organize a couple of events if they can continue and are not blocked by viruses, but I guess you all know this story. So the next 45 minutes or so, I'm going to start with some definitions to start off at the same page. I'll share the goal of continuous delivery. I'll share some of the principles and ingredients. I'll compare continuous delivery to DevOps. I'll explain why I think we should all practice continuous delivery. I'll tell you where to start and how to start applying CD to your organization. I have lots of continuous delivery patterns and anti-patterns to quiz you in the end, but I think we won't have time for this. I would like to leave some room for questions, and every story needs an end, so this one is no exception. So let's start with definitions. First of all, continuous integration. You probably all do continuous integration, right? So if you're sitting behind your computer, think to yourself, am I doing continuous integration? And keep that thought. So with continuous integration, team members integrate their work frequently, and commits are verified by automated builds and tests. So get back to this thought. You were probably all thinking we're doing continuous integration. So are all the developers in your team checking in code to version control at least once a day? And does every commit trigger a build and unit test run? And also, when the build breaks, is it fixed within 10 minutes? So I think if you follow all these three principles, then you are doing truly continuous integration. If not, you're on your way, but there's still some room to improve. So continuous delivery, I'd say it's basically a way to build and test your software in such a way that it can be released to production at any time. So it's about a way to handle quality and automation of releases and to make sure that you have a reliable process for releasing software. So nowadays it's popular to mix these two terms and to talk about CI/CD and CI/CD tools. So I don't really believe in the term CI/CD. I believe in, at one point, having continuous integration, which is about integrating software, and about continuous delivery, which is about having a process and maybe automation and tools to being able to get your software out there to the end user. And then there's continuous deployment. And with continuous deployment, you're automatically putting every change to a build and test pipeline. And once the build and test pipeline succeeds, it automatically gets deployed into production. So is continuous deployment the end goal for everyone? I wouldn't necessarily say so. So some companies are fine with deploying to production every 2 weeks. Continuous deployment has its advantages because you're basically deploying every change to production individually. So whenever something goes wrong, you can be really sure that it was that only change that you deployed. But it's not necessarily the end goal, I would say. And then there's DevOps. And with DevOps, it's hard to get a clear definition. Typically, when I have a conversation with people about DevOps, I get this idea. We're both using the term DevOps, but are we meaning the same thing or not? We don't really know. So I'd like to define DevOps as, devs and ops being responsible together for the entire product lifecycle. So it's not about tools. It's not about cloud or automation. It's about a team of people who have a responsibility together to go from idea in your head to working software in production. And that's basically it. It's about being responsible and being independent and being able to get kick-ass software in production. So how did this all start? Who invented continuous delivery? Well, that's not really clear, but it started with a book. And this is a book from Jez Humble and Dave Farley. It's from 2010. It has 450 pages, and in this book, Jez and Dave describe basically a process to go to set up reliable software releases by automating builds, tests, and deployments. So what is the goal? What are you trying to accomplish when you're practicing continuous delivery? It's a repeatable and reliable process for releasing software. So it should be repeatable, so you can do it lots of times. It should be reliable. You should be able to trust it. And it's about releasing software. So in its core, CD is about getting software out there to your end users in a repeatable and reliable way. And obviously, quality matters there and test automation matters. But in its core, it's a reliable way to get software in the hands of your end users. So what are the principles? What are kind of like the key points that define continuous delivery? Obviously, it's about automation. Automate almost everything you can. I'm saying almost because some things are just not doable to automate, or will take you so much time while it's only a small effort to do something manually once a month. But in practice, try to automate almost everything. Builds, tests, releases, documentation, provisioning of environments, scaling. The more you can automate, the more you know that things will happen in a predictable and reliable manner. Put everything in version control. So not only code, but also tests, documentation, infrastructure, configuration. Because when it's in version control, you can see who changed what when. And this helps you get into control. If it hurts, do it more often. And also bring the pain forward. So if there's something in your delivery process that's hurting you from, let's say, getting your software out there, that's costing you pain or slowing you down, try to practice this and become better at this. Because if something is hurting you, you should become better at it so it doesn't hurt you that much anymore. Obviously, quality is important. If you're going to do lots and lots of releases and you want to be successful in the long run, you need to focus on quality. Done means released. So if you are working as an agile team and you have a definition of done, and that definition of done does not include software needs to be installed in an environment, then I typically do not call it done. Because software isn't useful for your end users until they can really access it, or it's maybe on acceptance environment or something. But once it is still in version control but not installed somewhere, it is not done, because maybe you need to change something on the server, some configuration, or you need to build a server or scale something. So ideally include the installation on your target environment in your definition of that. And everybody is responsible for the delivery process. So not only the operations people, also developers, also the tester, the UX expert, the project manager, they all should be responsible for getting the software out there as a team, and not be dependent on only one or two people in a team. And there should be a drive to continuously improve yourself. So being able to continuously looking at what are we doing as a team, how are we working as a team, and what can we do to become even better and become more successful. So what are the ingredients of continuous delivery? If you would ask me for a recipe, what ingredients would you get? I'd say there are 5 categories. First one is about culture and your organization. Second one is about design and architecture, how you build and deploy stuff, how you test and verify stuff, and getting information and reporting on your application. So I'm going to zoom into these in the next couple of slides. So let's start with culture and organization. Obviously, the thoughts behind agile software development in working in small increments and doing frequent releases helps with continuously delivering your software. So I'd say agile software development is about building the right thing. So having one team, one prioritized backlog, working in small increments, and having quick and short feedback loops. Continuously checking, are we doing the right thing? But it's also about building the thing right. And this means focusing on clean code, on software craftsmanship, on actively reducing technical debt. So trying basically gardening your code base and making sure that everything looks fine. There's no like any weed or other stuff in there. You build as you run it. So this is a quote from Werner Vogels, the CTO of Amazon. And this basically means if you build something, you should also be operationally responsible for it. So you build something, you should also run it. If you are just getting started with this, it might turn into you build it, you ruin it, but you will get better at this over time. And personally, as a developer, I like also having the responsibility for how my app runs in production. Because if I know that what I'm pushing right now in the afternoon will break stuff at night and my phone will ring, then I will think twice about pushing crap code to production. Having cross-functional teams. So ideally, a team should have all the capabilities it needs to go from idea to working software in production. If there's one thing that's killing the performance of teams, it's being dependent on other teams or other parts of the organization. So ideally, a team should be independent, so completely self-organized, and have all the capabilities it needs to get a new idea in production. So you need to think maybe about front-end development, back-end development, test automation, infrastructure, data engineering, UX, and so on and so on. And I think mostly there should be room to experiment and room to fail. So I often get asked, like in the current way of working where we have self-steering teams, self-organizing teams, what is the role of a project manager there? So I'd say the role of the project manager is to try to enforce the things on this slide. It should make sure the team is truly independent, and also should make sure that there's a culture where it's okay to experiment, where it's okay to fail. If something fails in a project and it doesn't impact end users in production, then it's not really a failure, right? It's only a learning moment. And even if it does impact end users in production, it's probably a big learning moment. So try to find ways where it's okay to experiment, because experimentation can give you insight. And also where it's okay to fail, where there's no blame culture, where you can even celebrate to fail. So I've seen companies where they buy cake every time there's a failure, or if you have the biggest failure of the week, you get the best parking spot next to the director of the company, for example. So failure is actually where you learn. So having room to experiment and room to fail is a really good way for progression of a team. So let's talk about design and architecture. Obviously, version control. I've said this before. Make sure that you have code, documentation, your infrastructure provisioning, your tests, your configuration, all on version control, because then you can see who changed what. It's easy to revert, etc. Make sure that you have some sort of branching strategy, so how you handle branches in version control. So this could be either trunk-based development or feature branches or Git flow or something else, but make sure that you have something and follow this strategy. In the end, the goal is to have as little impact between concurrent changes as possible. So in general, having no branches or having really short-lived branches tends to be a good idea. Find a way to handle database changes. So in the current time with cloud environments, it's typically fairly easy to roll out a new version of an application. But what if you have 8 servers running and you're rolling out a new version in a rolling update? So at some point in time, 4 servers have the old version, 4 servers have the new version. And there's a database change in between. So 4 servers are talking the old database schema and 4 servers are talking the new database schema. This can be a problem. So make sure that you think through how you handle database changes. There are some good books about this. One strategy you can do is to make changes backwards compatible so that 2 versions of the application can handle the same database schema. You can also use automatic tools to upgrade schemas, but then you need to think about what do you do with rolling updates of your application and concurrent versions. So I'd say this is one of the harder problems to tackle, but it's an important one that you ideally give lots of thought and time to make this a non-issue. If there's one thing you can know for sure in IT is that stuff's going to fail sooner or later. So think about which things can go wrong in my application. Can I have maybe a network problem or a timeout, or can the application crash? What will happen? Do we have any dependent services of each other? So design your application with failure in mind. Think about which stuff can go wrong. Feature toggles are a nice way to disconnect the moment of deployment of a feature from the moment of release. So if you're building web applications, this is typically not really a big issue, because once you deploy something, the next request that comes in has the new version of the software. But say you're developing mobile apps, so for Android or for iOS. Let's say that you build a mobile app, you roll it out to your end users, and then you find out there's a problem in there. You need to go fix it, submit it to the App Store for review, wait until Apple has approved it, then it gets updated in the App Store, and then you need to wait for your users to download this new version. So this could take anywhere between hours, days, or weeks for your users to get the fix. So one solution you can use here is feature toggles. So a feature toggle is basically a configurable if statement in your code that enables and disables a feature that you can control remotely. For example, every time you start up the app phones home to ask, give me the current state of all feature toggles. So I know a company in the Netherlands that is using feature toggles extensively for their mobile app. So basically what they do is they add a new feature, they turn it off in the feature toggle, then they wait until the feature is enabled on enough phones, then they turn it on. They look at the metrics, like, is this working correctly? Am I getting any crashes or not? If it's okay, they leave it turned on. If it's not okay, they turn it off again. And maybe only for older devices, or for Android KitKat devices, or for iPhone 7s. But in general, this is something that you can configure on a per user or per device basis. I was talking to them about this, and I thought it was a great idea. And then I asked them, like, do you always have feature toggles for every feature? And then they said, well, there was a feature a while ago where we thought we don't need a feature toggle for this. It's so trivial. Then they released this feature and it became a big problem. So from now on, they are using feature toggles for every feature. Once you have a feature toggle enabled for all your users, and you make sure you know that you're not going to roll it back anymore, make sure to remove from your code base to prevent it from gaining dust there. Automated provisioning. So make sure that you have some way of automatically configuring and provisioning your servers. If you're still configuring servers by hand, this will probably cost you too much time and also introduce lots of errors. Because we all know the situation where something worked fairly well on acceptance and we deploy it to production and it didn't work because a configuration setting was different or because there was a trailing space in a property file or something. So if you automate provisioning of your environment, you can be somewhat sure that they are all fairly the same if they use the same provisioning scripts. So whatever you use for this doesn't really matter. You can use images, Docker containers, Puppet, Chef, Ansible, but as long as you have some way to make sure that your environments are provisioned and configured automatically. So let's talk about pipelines. So the definition of pipeline I like to use is a pipeline is an automated sequence of stages or steps to get software from version control into the hands of the end users. So the goal is to take something from Git, and the end result is a deployed environment in production. So I typically split the concept of pipeline in two. I'd say there's a build pipeline, and the responsibility of a build pipeline is to create a deployable artifact. So it starts with a push to version control, then a continuous integration server starts building, it runs the tests. Every successful build gets deployed in some artifact store, so Nexus, Artifactory, or a Docker repository. And there are also some quality checks in there. So it starts with a push, and the result is a release in an artifact store somewhere. And then there's a deployment pipeline, which basically picks up where the build pipeline left off. So you can talk about taking a release from an artifact store, and the end result is a deployed environment. So ideally, the input is maybe an application name and a version number, and the output is this application and version was deployed on this environment. So you can think here about automated deployments, zero downtime deployments, rolling upgrades, maybe even roll forward only deployments, so never go back to a previous release. And the end result is a deployed environment. So the benefit of splitting these two is that it's always possible to deploy an arbitrary release to an environment. So if you combine building and deploying, it becomes fairly hard to install a build from maybe a month ago. If you split this and you have an artifact store where you have numbered releases, then at any time you can say, I now want to deploy release 1.2.3 to my acceptance environment to try to recreate a problem that's now existing in production. So let's talk about tests and verification. So make sure that you have some sort of testing strategy. So here, think about what are you going to test with which types of tests. So you can do unit tests, integration tests, end-to-end tests, automated acceptance tests, or regression tests. Ideally, you have a healthy mix between those tests. So unit tests are fairly easy to write. They run really, really fast, but it's hard to get 100% coverage for your system with unit tests. Not necessarily that's the goal, but it's fairly hard to do so. With integration tests, where you are running a part of the system, it's easier to touch a lot of code, but they might break a bit faster. If you are making end-to-end tests, where you're testing the environment through maybe the user interface or through a REST endpoint, these tests they hit lots of functionality quickly, but they also tend to be fairly slow and fairly brittle, especially if you're doing UI tests in the browser. So find a healthy balance between the different types of tests so that you can gain enough confidence about your application and the quality of your application in the least amount of possible time. So test automation obviously is important. So make sure that you have some idea of how you're going to automate your test. It's okay to test some stuff manually, but this won't work out in the long run. So focus on automating all of your tests and have them ideally run at every commit for your application. And the nice thing about automation is it can really help, but it can also cause you trouble. So I'll tell a story about automation. It has nothing to do with IT, nothing to do with software, but it is a nice story about automation. So a while ago, I think it was about four years ago or something, I was at my parents-in-law's house with my kids. And my daughter was at that time doing potty training. So she was learning to use how to toilet. So she came up to me and said, Daddy, I need to go to the toilet. I said, okay, you go ahead, go to the toilet. She runs off to the toilet. And then my son, who was, I think, 1 at the time, and he was still in diapers, who said, like, Daddy, I need to go to the toilet too. So I said, okay, go ahead. So he runs off to the toilet. And then I noticed that there was a risk involved in them both going to the toilet, because the toilet at my parents-in-law's house is not a regular toilet. It's an automated toilet. So it's a type of toilet where you can press a button and then things start to happen. So it starts. It tries to help you. So my kids are there on the toilet, and I think I better go check this out. So I walk over there. My daughter is sitting there, and they're chatting, and my son is standing beside the toilet, and he's looking at all the flashing buttons there. So I don't want him to activate the toilet. So I make my first mistake there, and my first mistake was saying to a 1-year-old boy, Pim is his name, Pim, do not press that button. So if you're a 1-year-old boy and your dad tells you that you cannot press a button, this is the mission of your life, to now press this button. So he moves closer. I said, Pim, do not press the button. He moves even closer, and I cannot stop him because the toilet is between me and him. And I say, Pim, if you press that button, you're in big trouble. So he looks at me straight into the eye. I see a twinkle in his eye, and without breaking eye contact, he pushes the button. So the toilet starts activating. So I think what I need to do, I need to save my daughter, because if she stays on here, she's not going to the toilet for the next 10 years or so. So I reach over, I pick her up, lift her off, and at that moment, the toilet activates. So it starts spraying water wildly. Everybody is wet. My kids are crying. I'm wet. There was one nice thing, is that the toilet water was warm, but apart from that, it was a big mess. So why am I telling you all this? Well, I'd say that moral of the story is automation is only as good as its ability to cope with the unexpected. So this was unexpected behavior by the user for this toilet. So I'd say in this case, I would have designed the toilet in such a way that it would not activate if there's no behind above it. So I see one of the comments that Pim is a badass. Yes, he is, but don't tell him. I will tell him later, maybe. So more of the story, think about how you automate stuff. But because if you think about your production environment as the toilet at my parents-in-law's house, if you automate stuff that automatically does things, that fixes things, also think about what happens if the automation goes wrong. Will it break stuff? Will it screw stuff up? So also here, think about ways in which the system can fail.
I'm just starting to catch my breath again. Very good, very good.
Yeah, I see somebody in the comments that it's a CI/CD toilet. Yeah, I guess we can say that.
This will be the talk with the toilet story.
Yeah.
There's also a question, I think, that perhaps fits into that Rolf Wagner asks. Could you give a recommendation how to implement a manual approval if your organization requires it for production deployments? Would something like that help in such a situation?
Well, I think we can move away from the toilet story. But I think what can help is if there's a request for manual approval of something, this is typically a trust issue. So the manager that wants to have manual approval either doesn't trust the team, or doesn't trust the tooling, or wants to do some sanity checks him or herself. And I think that's fine as an intermediary step to get the organization to trust the system. So, for example, if you're building pipelines with Jenkins, there are manual confirmation steps you can build in. I believe that most of the pipeline tools that are out there have some sort of manual verification that you can do. And this can really help in building trust in what you're doing and in the system. So if this helps in automating stuff more, so if you can choose between either doing everything manually or automating stuff with a manual approval, I would definitely go for the manual approval. I think that's fine. The end goal would be that there's enough trust in whatever you're doing that there's no manual approval necessary. But as an intermediate step, it's perfectly fine.
Okay. Now about since you're talking about test and verification, there's also the question, if you have a recommendation about the unit tests code's coverage, or what is your experience there?
Yeah. So how high should unit test coverage be? Well, obviously, you would want me to give a number, but I'm not going to give a number. I'd say it should be high enough to have enough confidence in your automated test that you can deploy something to production. And this would highly depend on the type of organization and the type of application you're building. So in general, I'd say that 100% test coverage is probably not feasible or really a lot of work. I don't know, anything below 50% is probably on the low side, but where you are between this 50 and 100%, it depends on how good your application is and how much trust you have and how much manual stuff you're doing. So in general, I would say you need to trust your tests in such a way that you're fine with trusting automated tests in verifying the quality. And once you've trusted your test, you're okay with deploying into production unseen, so to say. Okay, since we were into telling stories, let's continue. There's one more story about the company where I was building software for insurance companies, and this was I think an insurance company where the premium of your policy depends on where you live. For example, if you want to insure a bike, in Amsterdam, it's a lot more expensive than you would insure a bike in the north of the country, in the Netherlands. So you need to absolutely enter your postal code because it's mandatory to be able to give you a quote for your insurance or to calculate the premium. So one time the client calls in the morning in panic saying, nobody can enter any new policies because the postal code check fails. So we're looking into the problem and we're seeing that the postal code table in the database is empty. So it doesn't find any valid postal code, so nobody can enter a policy. So we quickly start the batch job to fill the postal code table again, and then it's good to go again. So the client is out of trouble. Then we start investigating. So how did this table become empty? So did we run any jobs or something? No, not at all. Look in the logs of the application, we can't see anything. Okay, maybe look at the logs of the database. And then we go to the transaction logs, and there's a truncate table postal code statement in there. So we're like, that's interesting. What's the deal there? And then we ask like the hosting company, like, did you do anything? No, we didn't do anything. Did we do anything? No idea. So we have no idea how this table got truncated. And then we're like in a team meeting and trying to think through what happened. And then somebody asked like, how long ago is it that we went to production? Then we said, well, it's about a year ago. So is it about a year ago or is it exactly a year ago? We look back in our calendar. Yeah, it's pretty much exactly a year ago. So we usually do clear the postal code table before we go to production, right? To get rid of the test postal codes. Yes, you're right. Okay, maybe that's a problem. So we start looking back in our mails about cleaning the postal code table a year ago. And then we see this message from one of the people from the hosting company. And it was cleaning postal code table. They were saying, yes, I'm currently in the train, so I've scheduled the deletion. Well, I guess interesting, scheduled. What would he have meant with scheduled? So we're then asking the hosting company, like, are there any scheduled jobs on the database server? No, nothing, no cron jobs, just this special.sh that's always been there. I'm like, that's interesting, special.sh? What's in special.sh? Oh, I don't know, it's been there forever. Can you send us the contents of special.sh? So he sent it, and special.sh contains a truncate of the postal code table. So at that time, the person was in a train and wanted to make sure it run. So we scheduled it using a very specific cron statement. So it runs on this day of this month, on this day of the week, I don't know exactly. But it turns out that it ran exactly the same a year ago, and this is why it cleaned the postal code table. So also there, think about how you automate stuff and think about things that can go wrong, and also think about the future. So non-functional requirements is also something you need to think about. How are you going to test non-functional requirements? So what are non-functional requirements? I would say that non-functional requirements are requirements that if you do not need them, they make the system non-functional. So in this case, this car could have used a load test, I would say. So what are typical non-functional requirements? Stuff like security and performance. So ideally, you also incorporate security testing and performance testing in your build pipeline, so you can get feedback on this as early as possible in your development cycle. And then it's also nice if you have some way to verify the expected business value. So you're building a feature, and this feature should bring some business value to the end users. Find ways that you can check that this feature is actually used and actually providing value for your end users. So you can do this by metrics or by interviewing users, for example. So one story about this is that I was building a system for a company where we were making some kind of form, and in the end, the form should be exported to the back office of this company and then imported in their mainframe automatically. So we were factoring some stuff there, and then we said, okay, so there's a print button on the last screen, but nobody's using this anyway. So we're planning to remove this button, since you're exporting everything and importing it in your system anyway. And then we got a call pretty quickly from a fairly high manager of this organization, and this manager said, whatever you do not remove this print button, it's vital. So okay, we will keep it there, but why? Yes, discuss this with the team, but you cannot remove this print button. Okay, that's strange. So we call the team at the client and say, so what's going on with the print button? Because once the form is submitted, it gets exported to you, right? Yes, that's correct. And then it gets imported in your mainframe, right? Well, yes, that is how we planned it, but we never got to building this. So how do you then get all this stuff in your mainframe? Well, at the end of the day, we print all the forms, then we bring it to somebody at the mainframe, and he types it in at the end of the day. So it turned out that this feature to export everything wasn't used at all, and the print button was used as a way to compensate for this. So always make sure that you know which parts of the system are used in which way by your end users. So let's talk about information and reporting. So how do you get an idea of how your application is behaving? Obviously, static code analysis can help. So think about quality metrics, stuff like sonar, test coverage. Find a way to have traceable pipelines. So ideally, you can trace a change from requirement in your issue tracker to, task in a sprint, to commit in version control, to merge request, to code review, to build, to release, to deployment. And you can trace this all the way too. So you can see, for example, how long it took to get something out there, but also who worked on it along the way. Find a way to automate the making of your change log, so the release notes for your application. So probably all of you have the favorite activity you're doing in software development is to automate making change logs of your application. And this is the favorite activity of nobody, right? So you can try to automate this by either exporting this from your issue tracker or from your commit logs, but then you do need to have the discipline to make commit messages that are understandable for end users. So to give you an example from the wild of a commit message that is not really descriptive, this was bonjour is French for hello, which is an awesome commit message by itself, but it doesn't help the users in any way. So if you have the discipline to write really good, story names or commit messages or merge request comments, then you can automate this. Users metrics. So it turns out to be handy that you know how much a feature is used. How many times per month does a user click on this button? So to give you an example, I had a feature that we wanted to remove from a system, and the product owner was absolutely sure that it was a really important feature and was used a lot. So in secret, we added metrics for this feature just to see how much it was used. So a month later, we went to the product owner and we said, we're going to remove this feature. No, you can't, but I'm sure it has been used a lot in the past month. And he said, yes, it was used 5 times, only by you, not by any other users. So then we had a good discussion because we could talk based on numbers and not based on feelings. Dynamic dashboards. So ideally, you give your users away, the different stakeholders of your application, to create their own dashboards. So operations has other dashboarding needs than a product owner. And the product owner has other dashboarding needs than maybe an information analyst or a data analyst. So find a way that you can give analytics data to your stakeholders and they can create dashboards with this themselves. And this, in the end, will enable you to make decisions based on data and act on metrics and not based on feelings. And this also helps you to fix problems before your users even notice. because you can see in the metrics that error rates are going up, or that response times are going up. So this will help you to stay on top for the operation of your application. So let's compare continuous delivery to DevOps. So first question is, what was first, CD or DevOps? So DevOps was first presented in a session at a conference in Toronto, I think. The session was called Agile Infrastructure. It was presented by Andrew Clay Schaefer in 2008, and it had only one attendee, and this was Patrick Dubois, a Belgian guy. And these two are currently seen as kind of like the founding fathers of DevOps, and this was 2008. And the continuous delivery book is from 2010. So I'd say they're from about the same time. So what is DevOps? Well, it is about development and operations engineers, and they are being responsible together for the entire life cycle of a product. So I said this before, it's about responsibility. A bit broader definition, it's about developers and other IT professionals. So it's not only about devs and ops, but also testers, project managers, everybody in the team. And they're working together on a shared goal. And this shared goal is basically better software in production. So it's about building and running better quality software quicker and more reliably. So why should you do this? It sounds pretty hard, right? So DevOps helps you to make your business move faster. It helps making your business win. And it does this by becoming an enabler for continuous delivery. If you're doing DevOps, continuous delivery becomes easier. And it helps you to resolve problems faster, and also to focus on adding value instead of fixing problems. So what is it really about? What is the core of DevOps? I'd say it's about culture. So it's about reinforcing culture with technology and vice versa. It's about collaborating, cooperating, communicating. It's about being agile and being continuously wanting to improve yourself. And this culture is typically a culture that works well as a culture of freedom and responsibility. So freedom is nice, but the price you pay is responsibility. So take responsibility in the team, trust your teammates, and design a system in which people are held responsible for the consequences of their actions. So it's not about blame, it's being responsible for consequences. So create cross-functional teams, and you build it, you run it. And I think mostly DevOps is about empathy. So being able to place yourself on somebody else's feet and explore the world from their point of view. So the DevOps means giving about your job enough to want to learn all the parts and not only just your little world. So empathy allows you to view other teams as enablers rather than as blockers. So be likable, be approachable, and get stuff done. Then I see you think, well, it all sounds pretty cool, but it won't work here. So this is by a talk from Jess Humble, one of the founders one of the initial founders of continuous delivery. And he's saying, people are saying continuous delivery won't work because we're regulated. Well, Amazon is regulated and doing 1 million deployments a day. We're not building websites. Okay, HP is doing continuous delivery on their printer software. We have too much legacy. Okay, there's patterns for this. There's a Strangler pattern. There's lots of stuff you can do. And also, our people are too stupid. Well, typically there are people too stupid, but it's not the people actually doing the work, but mainly the people that are on top of those people. So while the actual reasons are, we have a culture that stinks, or our architecture stinks. So I think you can do continuous delivery in pretty much every company. Sometimes it will be easier to do it in companies than other companies. All right, so I'm about to wrap up. Why should you do all this? It's about reducing errors, lowering stress, empowering teams, and being able to deploy flexible. And when you practice, you become really good. So to summarize, I need to skip some slides because we are out of time, but that's fine. To summarize, why are we all here as software developers? What is the goal of a software team? So I'd say the goal of a software team is to create working and useful software and get it into production. And I think there's only one way to do this, and this is continuous delivery. So thanks a lot for your time. If you have any more questions, feel free to ask them in the chat. I'll be there for the next couple of minutes. Enjoy your day, and hopefully we meet in person at one time. Thanks a lot.